Hi, I'm Piotr Miłkowski. In this paper, we present the studies on personalized emotion recognition in text perception in the multitask setting. We analyze the performance of the joint learning of the model within groups of similar tasks, and for all tasks learned together, versus the classical approach based on separate models dedicated to each individual task. During that presentation, I make you familiar with motivation of our work. What are personalized models? What is the difference between multitask and single task approaches? And results of the experiments that we performed. Text's main role is to transmit information between people. Nevertheless, in addition to its informative, factual role, it can evoke different kinds of emotions among the recipients. Therefore, one of the problems considered in the domain of natural language processing is the recognition of emotions evoked by textual content. Most work focuses on building models capable of recognizing one dominant emotion, reflecting the most popular human reception. It is achieved by the acquisition of textual collections annotated by some human annotators. How does it work that you feel emotions? Let's say that you watch a movie, see some photographs, read a book, an article, or some kind of newspaper. You participate in an event, you have human interactions, you do physical activities. All of that evoke emotions that we are self aware, therefore, we can report them, or, for example, create text annotations. During the annotation process, you present the text to the participants of your study. Here on this slide, we can see an example opinion that was presented to 54 annotators. But if we look closely at the data, it's clearly visible that different people gave different answers. For example, John gave mostly positive marks, while Elizabeth gave mostly positive answers. Therefore, there's a lot of room for personalization. However, different opinions are not the only problem that we noticed. Emotions elicited by that opinion also overlap, they mix. Therefore, we have to predict a lot of them in the same time. In case of first problem, personalized models are our solution. While most works focus on building models that are able to recognize one dominant emotion reflecting the most popular human reception. It is achieved by the acquisition of textual collections annotated by some human annotators. Next, majority voting, averaging, or simple selection of text are utilized to obtain a general perception of individual documents. We, however, proposed personalized solutions that treat the text with respect to each individual. The annotator's personal bias is an aspect to consider, specifically when performing emotion recognition from text. It might come from different factors, such as age, education, demographic background, language spoken, gender, and race. If we ignore personal bias at this stage of model creation, we risk a significant decrease in its effectiveness. The consequences of personal bias can be omitted by limiting to annotations provided by the experts only, averaging annotations from non-expert, grouping like-minded annotators, creating an ensemble model from personal annotations, or using a separate set of annotators in the training and test set. However, the second problem is the problem of multiple possible answers and how to predict them in the most efficient and effective way. At first, we tried single task approach. That means that we trained a separate model for each of the dimensions in the dataset. However, we checked that positive emotions correlate with each other, and also correlation between negative emotions is significant. Therefore, we considered a sub-multitask approach, where we grouped positive emotions and negative emotions, as well as violence and emotional arousal, into different models predicting the whole group at once. And the last approach that we thought of was multitask. That means that we have multiple emotions predicted at once from the single model. For our experiments, we used state-of-the-art language models that provide very precise text representations for single language as well as cross-lingual text representations. We tried 4 different model architectures. First one, as our baseline, was looking only on the text representation. Second one concatenated text embedding with one hot containing user identifier. Third one was using concatenated text representation with z-score from the user's answers. And the last one, the most complex one that we tested, was using both text embedding and embedding of the human being. The mentioned model looks like that. At first, it starts with randomly generated human embedding values, but later, during the training process with backpropagation, human embedding is fixed into the values that give the best possible outcome for each individual user. To achieve that, we performed a study on a dataset with 7,000 opinions. Each was annotated by about 54 people with intensity of 8 basic emotions from Plutchnik's model. Those emotions are trust, joy, anticipation, surprise, disgust, fear, sadness, and anger. Additionally, they scaled also 2 more dimensions, valence and emotional arousal. As you can see, in the user text annotation approach, variant using only text representations was in order of magnitude worse than personalized solutions. And within them, it is clearly visible that joint solutions, I mean sub-multitask and multitask, were far better than single task approach. In our research, multitask approach gave more than 15% improvement over single task approach. To quickly conclude our research, we can formulate 3 statements. The first, that personalized methods give in order of magnitude better results in comparison to generalized text-only based approach for prediction of individual opinion. Second one, that sub-multitasks are far better than single tasks, especially when used in groups of dimensions with strong correlation. The last and most important one, that multitask approach, sharing the knowledge of all dimensions within a single model overcomes both sub-multitask and single-task approaches in parallel emotion recognition. Thank you for your attention and feel invited to join us during the question and answer session on the conference.